Okay, so the recording has started. This meeting is now being recorded, and by continuing to be in this meeting, you are consenting to be recorded. Okay. All right. Welcome everyone to our Module 1 webinar, and good evening, good morning. I don't know, good night. I should good night after some time, but yeah, please, not good night. Let it be good evening for you, Alex, right now. Okay, so I'm just going to skip this. And I think we are doing very good with this. So I'm going to skip all these stuff, and you can chime in anytime, Alex, or for any questions or anything of that sort. Okay. And as far as the meeting goes, I kind of set an expectation. Hopefully, I would want to kind of get this done within the hour. But max, if it goes, maybe it could be at 5 to 10 minutes more in case we go based on that, but nothing beyond that. Okay, so what are we going to do today? So I want to talk a little bit on just a little retrospective here, right, on big data and Hadoop ecosystem. Don't want to go over anything that you would have gone and done it. I think it could be an overload here. So I want to kind of, far from it. I don't want to kind of go over that one more time in any way, but see if I can supplement what you've gone over, right? And maybe you would have gone through this multiple times, right? In other courses, and maybe, doing it here again. But I just want to do like a quick recap on the week by, and I'll tell you that you'll get to know the reason why we are kind of doing that, or why this is so important, right? Your week one. So we'll kind of go over that. Next, and most importantly, what I want to touch upon is your assignment one, right? Very important. This is your very first assignment, and still pretty comprehensive if you think about it. Maybe many of you, or Alex, you would have gone through this yourself already, taken a look at it, and it may look like a few pages of a document it is of description and the steps you need to take, but we'll kind of break it down and make sure that you understand what is required here and address any questions that you may have. And then, of course, oops, I'm sorry. It just flipped over. I don't know why it did that. So give me a second. Okay. And last, and just your questions again in general. Right. So now moving on, just a little recap, and then this is mostly on the recap on the discussions here. So I just want to do like a quick week one retrospective here, and starting with the discussions of course. So just want to mention, your discussion postings, you all, whether you're in the meeting today or you're watching this recording, I want to let you know, guys, that your discussion postings were with real good quality. I enjoyed it, and I tried to address or respond to and read each of your discussion postings, because they're really important. And being this a small class really gives me an ability and time enough to kind of respond to you and have that kind of conversation started, right? Many of you have embraced the spirit of engagement and participation by reviewing your classmates' posting, right? I've seen many of you kind of already doing that, right? You understand what is required here. And it's in the spirit of you engaging with your classmates and sharing your ideas, sharing your thoughts, brainstorming your own ideas in a way. So that's what is the whole idea behind having this particular step here of reviewing your classmates posting. And and what I want to kind of suggest, knowing the couple of folks, and I see that we have one more classmate of yours, Alex, here in this webinar. So we have 1/3 of a class here, but I wish really most of the classroom is here for the webinars, or take advantage of this webinars live. But if not, at least my expectation is that you're going over these recordings if you're not able to attend for any reason. Okay. Just about the discussions again. So no late submission is accepted for discussions. I just want to make this very clear, and I did put this out much in advance. You would have probably seen this in the classroom. I had put this very clearly. There's no late submission, there's a due date, and all of that that's been attached. So that's one thing you always want to keep in mind. And for that, it would make sense, to kind of make your initial posting as soon as possible, right? And I understand that you have tons of reading material to go through. You may not be done by the Saturday of your class week, but if you can, right? If you can do that, by the end of Saturday or maybe early Sunday, you want to put it out there so that, your classmates are going to also read it, review it, respond to it, ask you questions, brainstorm it, and take your learning forward, right? They enhance your own learning. So it's very important that you could, do that earlier. Now comment on at least two of your, oops, why does it go away? I'm sorry, this is acting really funny. Okay, so comment on at least two of your classmates' initial postings, and I mentioned that. I don't know why my screen's not working today. It is trying to have its, brain of its own, a mind of its own. Anyway, so post your reply to a fellow course participant who has responded to your initial post. Very important. Once again, it is like, if somebody has responded to your initial posting, you want to kind of reply them back, right? At least thank them for reviewing your posting, or maybe whatever, if they've appreciated some of it, or if they've asked you a question, that you have time to respond to it. And sometimes nobody happens to respond to your question, right? And especially if you have chosen to submit your initial posting, which is close to the end of the week, which is Tuesday, very likely, I've seen a posting as late as like right after 9 p.m. on Tuesday, which is you almost kind of gone about the beyond the window of time when somebody would be reviewing it and posting it. But if that happens and the class week is almost over, then respond with additional comments to your own initial posting. Okay, and I want to make this very clear, guys, that it's not that you're just going to do your posting of your initial post and comment on the other two. But if nobody responds to it, because you've not given time for anyone to respond to it, then it's up to you. You will be, you're asked to and expected to respond to your own initial post by providing additional comments, right? That is going to enhance your own posting, right? Or add some more information to it. Is that clear? Okay. Any questions on this? By the way, this was also posted in the announcement, but if there's anything that is not clear, this is your time to ask. Okay. Take that silence as no. So want to just talk a little bit about big data, right? You guys, once again, I know there's an overload of material. You had lots and lots of things or material to read about big data, which you may have read before as well, which I believe in other courses. So let's validate these statements, right? And these are the statements that you may have already heard from someone or may hear from someone, because trust me, I still get to hear this myself, even today, from my work peers, or from my, friends or whoever. But, let's validate if these are really true. What is going to be your take on these statements, right? I want to know that. So anything that I'm unable to store on my laptop is big data. What do you guys think? Is that a true statement?
I think anything that you cannot store on a conventional machine, laptop or otherwise, or a single conventional machine would be considered big data if it is data, at least in first and foremost data, and then secondly, too big to be stored.
So you think that this statement has some value, that if you're unable to store something on your laptop, automatically becomes a big data?
Unable to be stored on a single reasonable machine, yeah.
Okay. So if your machine is 500 MB, right? Let's say for sake of discussion, 500 gigabytes, sorry. And you have a data which is 1000 gig, right? Or 750 gig. Of course, it's going to blow up your machine, right? You don't have that much data. Would you call that data as big data?
Yes. I feel like I'm walking into a trap here, but I'm going to say yes.
No, that's okay. No, I'm not putting it in a trap. No, this is not a trap at all. This is good. I'm glad we are kind of talking about it, because trust me, I get it from people who also are kind of working in this field. So please, don't think that I'm trying to put you on a trap, or this is going to put you on the spot here. This is for our own learning. And let's get this out. How about the other Alex who's joined us?
I think I kind of agree with that. But I think there might be a smaller like niche situation where perhaps you have a smaller data set that updates very frequently.
Okay.
So you could still technically store it at any given point, but I think based on the nature of it, it might still somehow fall into that category.
Okay. Okay.
So I
you
feel like
both-
based on the size, yes, but I feel like there might be some other parameters that might push it that direction.
Okay. Okay. So hold on to your thought, and we'll kind of come back to this. But okay. So first statement, you both appears to be okay. Not too bad, maybe true. The next statement, let's take the next one. Unstructured or text data is big data. What do you guys think about this statement?
I'm going to say it just by the nature of being text data or unstructured, blatantly false to call it big data. I have a collection of Word documents in my classroom folder, for example, that would all be text and unstructured data. That's not big data.
So you kind of agree with this statement, Alex? That's what you're trying to say?
No, I disagree with this statement.
You disagree with this statement? Okay,
yes.
So I just wanted to clarify. How about you?
Yeah, I think I also disagree. I don't think a certain type, just because it's text, makes it big. I think there has to be something else with that.
Okay. Alrighty. Okay, then the last one here. The size of data has increased due to pictures and videos. So our small data has become big data.
I'm not quite sure I understand what this is saying. I mean, certainly we can store pictures and videos, and that makes data from, we could have stored in 1943 much bigger than we can store now, but.
So is that just because your pictures and videos that are like large size pictures now today, in today's world, your one picture could be even 64 megs, right? At one point in time, that was like absolutely 64 meg was almost like it would blow off your machine kind of, thing situation. But now we have like each picture now. So can we say that whatever we have now, based on the fact that we have all sorts of data like pictures and videos, now it has become a big data even in your PC? Did I clarify that statement before you answer, Alex? Did I clarify?
Yes, please.
Okay. 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 Go ahead. Go ahead.
So I would say that the nature of data we've been able to collect is larger, but the nature of data we've been able to store on single machines is also larger. So again, just by virtue of being pictures and videos, it does not make it big data.
Okay. How about you, Alex? Other Alex. I know you have two Alex joining.
Yeah, of course, both of us showed up.
I don't know. Maybe I have to go with your last name. I would hate to do that, but I think I will have to probably at some point.
Most of my friends call me Alejo, so if you just want to call me Alejo, that works perfectly.
No,
yeah, that could work.
That sounds a little weird, though. To be honest with you. Okay. Anyway, yeah.
I think I see what you mean. You're saying that as technology is getting better, like just a single picture can contain more.
Yeah.
More like pixels, more quality, that kind of thing.
Right.
So I would say there's certainly scenarios where you could have like a collection of pictures or videos that would be big data.
Mm-hmm.
I actually just had to clear a couple gigabytes of like pictures and videos off my computer. So that stuff adds up pretty quick.
Right. Right. So now do you think that you have big data on your laptop now?
I don't know if
the data on your laptop now big data because you've got lots of pictures and videos. As a matter of fact, our phones these days have got lots of pictures and videos. So do we want to say that we are carrying big data now every day?
I would say we're carrying parts of it. I don't think of just what I have as being big data standalone, but
okay.
I guess in a way it kind of is.
Okay. Okay. Very good. Okay. So hold on to your thought once again, nothing right or wrong, but I want you to kind of bring you to this picture here, to this view, right? And I know there are you must have read about 3 V's of data, or 3 V's and 4 V's and 5 V's, and there are 6 V's and even 7 V's, right? I don't want to go that far, right? Because I think for this discussion, the 4 V's are pretty relevant. And I think if I had to kind of characterize anything as big data or really compare between big data or small data or whatever the normal data, I would kind of look at this particular chart, right, or this picture, and look at all these four different quadrants, because it's easier to remember the four parts of it really, or the four big major characteristics of big data. First is the volume, right? Huge data, volume or data size that we're talking about here. We're talking about terabytes, we're talking about petabytes, so on and so forth, right? And this goes on increasing. So huge volume, that's characteristic number one. Characteristic number two, you could call, let's go from the top to bottom here, right? Okay, so from volume, go to velocity, right? Something that's coming at a very fast speed, right? Something that it has got some speed, it has got some flow, it changes in the flow, or it does all that, or you need to do some processing while you're bringing or ingesting that data, all of that, right? Everything's happening at a faster pace. So it's velocity. Like, for example, like, if you think about, if you're sitting in a Facebook or Instagram or WhatsApp, kind of these offices, right? And if you're just watching by all the messages fly by, think of the velocity that it would be going through. Of course, forget the volume, right? Volume, we all know, right? There's millions of users on each of these, social media apps. But if just by looking at how fast this is going, many of this data, I'm just talking about social media apps. You can talk about the other companies too, who are kind of, getting all these data at such a high velocity. The third characteristics, variety, right? You're seeing all different types of data sources that are from where your data could be coming, right? It could be coming from, social media or mobile phones, or your structured data, or it's an unstructured data, and so much. It's a huge variety, not just of data sources, but also of the type of data. It could be structured, unstructured, from mobile phone, from your machines, from different servers, from your these machine sensors, right? These are all these different sensors that are now, that are generating data at such a fast speed. So all those automated data, the server logs that get generated, the user logs that get generated, all this kind of different kinds of data, veracity of data, right? Whether it's, and to, we're getting data of various levels of reliability and uncertainty and precision. Not 100% the data, you have to do a lot of processing, interpretations, and all of that while the data is coming in. It may not be a clear cut or a clean data by itself. You have to do something much more on the top of it. So when you see all these characteristics come together, that's when you would kind of, tag something as big data, right? So now going back to those statements, think about all those statements, right? So, anything that I'm unable to store on my laptop is big data? Maybe not, right? Because it's not just about your laptop. It's not just about your laptop. Could be a Chromebook with the smallest amount of memory. My laptop could be a MacBook with having, I don't know, a half terabyte or a terabyte of data. So can you say that anything more than 1 terabyte is going to be a big data? Maybe not, right? Because once again, still we're talking about volume. We are not even talked about the other things, but we're talking about terabytes and terabytes of data and petabytes of data, right? So they're not really true, the first statement. Second statement, unstructured or text data is big data. Once again, it's not just unstructured or text data. And you both were right on this one, because you could not, just because you take a Word file, and Word file cannot become a big data just because it has got a bunch of text and a bunch of paragraphs, right? It's not true. Size of increase, yes, size has definitely increased, but it doesn't mean that it has all of a sudden become a big data. Yes, my data size has grown huge. The computers that were considered, like really like a football playing field, but just by having 100 gigs has no meaning today, right? Maybe a few years back, you'd say, wow, I've got such a huge machine. Today, there's nothing, right? It just goes over like this. So once again, it all it's relative, but once again, it doesn't become a big data just by the size of data storage that you have for these types of data, because then you start applying the other characteristics, right? How fast it is, what's the pace of this data coming to your data source? What's the different variety? What's the veracity of this data? That's what is going to be, that's when you will be able to apply or tag any data to be big data, right? So now looking at the sizes comparison, right? Not going to go through this entire table, but you get an idea that, anything like small data, the examples could be your data, which is like, if you look at the examples here, sales records, customer database, hundreds and thousands of records, could be your personal computer. You could manipulate it with Excel, with R, or basic statistical software. It's all small data, megabytes of data. Large data, something like gigabytes and terabytes of data, like huge databases, right? Big company databases, millions of records, which mostly structured data, and workstation or server workstation computers are being used, RDBMS are being used. These are typical tools that are being used for managing this data. That may be just a large data, not big data, right? Then you have, you have customer interactions, you have social media, you have mobile data, you have multimedia, all these images and free text and everything. And you're talking about over millions and millions of records, which is distributed across multiple machines. And that's when, and the tools that you would need to manipulate this data is going to be either it's in cloud or data centers, large data centers, distributed databases. You're talking about Hadoop. That's when you characterize it something as, oh, you are really talking about big data now. You're right. So that's how you can differentiate between, seeing a small data to a large data to big data. That makes sense. Does this really help? Alex and Alex.
Yep,
Yeah,
that makes sense.
Okay. Okay. All right. So I know you kind of went over different use cases of big data, right? And they were really nice. Some of you had come up with some good ones in your posting as well. And there were some in the reading material. I just wanted to kind of just add on to few of the, recent big data use cases, which are really very, very innovative, right? And first of all, maybe you would have heard about this one though, because, it talks about the resumes, right? A lot of companies are now getting into something called as smart recruitment, where it's no longer just matching your resume keywords with your descriptions and finding out the best candidates. It is getting the 360-degree view of the candidate. That has become the norm. And what I mean by that is it's not just your resume, but what's your social footprint, right? On the internet. What's in on your Facebook, on your Instagram, on all of that, right? All that data is brought together along with your resume to come up with who's going to be our best candidates, right? So that's what is now happening. So a lot of that, and one of the reasons why you may have heard whenever recruiters are talking to you all and saying, guys, if you are in the job market, or maybe your friends would have said that, if you're in a job market, make sure you don't have some pictures or things on Facebook or Instagram printed or posted. They're not maybe really helping your candidacy, right? So because a lot of companies are now doing what I just mentioned, smart recruitment, right? Then the other interesting use case is this optimized supply chain and logistics management, right? It is like improving efficiency through sensors and variables, like use of GPS and telemetry data to find out what is the best optimal or delivery route, right? And you must have heard about this being used a lot by big companies like Amazon, right? All those Amazon trucks, the FedEx trucks running around. And sometimes those delivery times, it doesn't make sense, right? Oh, why am I getting this 5 days later versus my next door neighbor or someone who is 2 streets away from me is getting next day or tomorrow? So sometimes it would not make sense, but I think it is all based on what delivery route they get and how the trucks have been going around. So that's why, some of these delivery timings and all, they try to do the best to get things to you at much faster pace than what they used to do in the past. But it's all about making the best decision for the delivery route. Something that Amazon started a couple of years back. And I don't know, they have not really gone too far ahead with this because there are a lot of privacy issues. And that is about the anticipatory shipping program. Just based on what you've been ordering, how frequently you've been ordering, they would want to anticipate some things for you before you can even order. So for example, I'm buying something on a monthly basis. Maybe I don't want to buy. Maybe I'm not putting in a recurring order. Maybe I'm ordering, clicking on every month. They just want to just do it for you and say, oh, Lanesh is buying this every month. And maybe this month he has not clicked on the order button yet, but let's still send him that because he will need this, right? So it's anticipatory shipping program. Now, once again, I think the reason it has not become very popular is because of the, as I said, all privacy issues and things like, well, I do not want it this month. Why are you sending this to me, right? They were getting a lot of those kind of issues, getting into those issues. So they're trying to resolve that. And maybe this will come in a different, maybe later it would come up again, or maybe they will come up in a little different form. They may change the model a little bit. And to make it a little easier, maybe asking the customer before sending it, things of that nature. But yeah, they're already working on it. So it's just another, good example, a good use case of big data. Enhance in-store experience. I don't know if you've heard about this, but we just kind of came across this a year back. We had someone kind of come up and present one of the things that they were going to patent it, and this is like, and now it's becoming kind of more common and popular, is you are approaching a bank, right, or a store, and while you're approaching, and because of your mobile data and all of that being captured, and your profile being known to the store or to the bank, they would know, oh, okay, well, I see Alex coming here. Oh, Alex is in Munich and he comes to this place all the time. And here he comes again at this store. So before Alex can walk in, let me wish Alex, right? And you would see someone kind of an account executive or whoever is working with you would kind of come up and give you that kind of a personal service, right? What a service that would be to kind of see someone come at the door to kind of welcome you before you were really entering the bank, right? Or entering the store, or maybe having an announcement made, hey, welcome Alex, right? Welcome to our store. If you need help, reach XYZ, whatever, right? So giving that personal experience is another big data use case. And I think a lot of banks are experimenting with it. There are large department stores that are experimenting on it. And this could be huge, guys. It's all about that personal touch to your customers. Then we have the 360-degree citizens view, right? Where there are some government agencies that are trying to work on to connect your telemetry data, your health, your family connections, your registration data, like, maybe like Social Security, right? Or your passport, your bank, your real estate, your everything being tied together. Now, once again, as soon as you see all of that come together and being used by an agency, there's always going to be all those issues coming up, like privacy issues, right? Why is my data being used, or how is it being used, or whether it would get, how secure is my data being kept? So all these things that are still being worked, but there are government agencies that are working on this aspect very seriously, much more than what you think. Like, for example, I just learned the other day that few years back, and maybe now they're done, but the government of India, they had taken the fingerprints of more than 900 people, 900 citizens, 950 odd citizens. And this was probably more than a couple of years back, few years back, they had completed that. So to think that they have 1 billion plus people, maybe they would have got to that number already, or maybe they're close to that. But the point is, having the fingerprint of each of their citizens, right, in the database, how huge would that be, right? Just having one piece of information. We are not talking about any other data here, just having that one piece of information. is going to be huge in so many cases. So, and so this is work in progress, guys. And as I said, like this is not going to be easy for any government agencies or any federal agencies or whatever, because of the fact that, yes, they have to manage a lot of things. They have to make sure that, there's ample security. They are going to be sensitive to people's privacy issues and so on and so forth. So anyway, so all these are some very good, big data use cases that makes very interesting and I think very innovative. Um, and I think the time has come not to just use the data that is being generated by the company or by the company that you may be working on, but also making use of all the data around you, right? Weather data, traffic data, social media data, right? You want to know about your products. It is not just about sending surveys to customers anymore. You start listening to what's Facebook, right? All the Facebook postings, what's going on in Instagram, what's being talked about and on Twitter, right? That's how companies are now getting to know about their products, right? How many times do you get these days a survey in the mail for the products that you're using? Hardly. Not many companies are doing that anymore because they have a way to do it, right? So my point is, think about that. Big data is not just about what is in your company, but also working with what is outside the company as well. Make sense? Any questions on the big data use cases that we just went over?
None from me.
Okay.
Nope, makes sense.
Alrighty, excellent. All right, so what I have next is I'm going to switch the gears now from big data to talking about HDFS and Hadoop. And this is going to be very quick because all I'm going to go show you, and this is, by the way, you're going to get this as well. So you don't have to worry, don't have to take any pictures or any snapshot. But I thought it was nice. I saw this illustration, and this is from Manish. So I kind of have put this guy's name who's kind of really come up with this few slides and few pictures of how the entire HDFS works, right? When a file comes in to be placed on an HDFS, what kind of transactional activities happen at that point, right? What kind of handshake happens? And he's put this in a nice picture form that I thought if you would just go through this, that like 3 or 4 slides here of all these different transactions, like writing a file, what does the computer tell the data name node, and how the name node goes over to the data node and all that. And if you want to read a file, what does it do, right? What if there is a failure, right? If there's a failure of the name node, what happens? What if there's a failure of the data node? What happens, right? So all that has been captured in a nice illustration, which I think if you go through it, you will you can skip a lot of reading material that or the reading that you have to do to just understand all these different aspects of HDFS, right? So take a look at it, and whenever you get this in hand, I know you've learned about it already. I know that whatever I was just talking about, you may already know, and you don't have to revisit it. But at any point in time, if you think you want to kind of do like a quick primer or like a quick glance through, or see what HDFS is, look at this illustration. You'll get it all. Okay. So not going to spend too much time on this and move on to MapReduce. And once again, another illustration here, right, of MapReduce. What does in summary, or in just like in one picture, just explains what MapReduce is all about, right? You have 3 different files here having certain types of data, right? In the first pass, which is the mapping pass, it just, each of these files just breaks down these different pieces or types of data into single chunks, right? So each of these files, now let's see, it has all these purple colored, elements put together, the dark blue colored elements together, the light blue colored, and this could be anything, right? This could be names, this could be customers, or whatever, or the products, whatever you'd call, but this is kind of just lining up all these different elements together. And then in the reduce phase, what it does, it says, okay, I want to just know what are all the different purples or the purple data elements in on all these 3 data files here, right? Or whatever that has been provided as an input. So finally, oops, I'm sorry. I don't know why it just quickly runs through. It's very sensitive today. But anyway, so what happens here is you see then the reduce, it just reduces the whatever you've done in the reduction phase, it just comes up with the final list of what you want to see, right? So it's actually the reduction is a conglomeration or the addition of all those chunks, pieces to put together and and reduced in a way that it will show you only the data elements that you were scanning in the first place. Okay, so this is a nice illustration here. Next, I want to kind of go through is the implementations of Hadoop, right? I wanted to show you and just take you through like a few companies that you would know very well, right? Like the British Telecom, which is having the implementation of Hadoop here, right? So BT uses the implementations of Hadoop and powered by, so it is using a Cloudera based Hadoop. So many of these companies have come up with their own customized or registered version of Hadoop, which is nothing but it's an implementation of Hadoop that is maintained or managed by a certain company, but they have their own customized version of Hadoop. So this is what a Cloudera Hadoop is being used by BT. Then, CERN is using, as which you all know, once again, it's a large hadron collider in Switzerland, and it uses the Hadoop cluster. So there's another large implementation of Hadoop used by CERN. Then you have by Western Union, right? They use Hadoop-based data analytics platform, right? From Cloudera. In 2014, they've been using the Hadoop platform. Then you have Yahoo using implementation of Hadoop here. They use a tool from Splunk called the Splunk's Hadoop tool called Hunk, and they've been using that for their data processing or data storage needs. So the reason for sharing this implementations of Hadoop here, one of the biggest motivation was to show that you could say that, yes, Hadoop was the first generation. Now we talk about, you'll hear about other technologies, like, you'll hear Spark and using Apache Spark and faster than and all of that. But, there are still people making use of Hadoop, right? And one of the reasons why, even in your reading, you saw that, you probably, one of the questions was, find out about the Hadoop-based jobs, right? So you went through that and you saw that, oh, if I have to just do this, I went to indeed.com, right? And many of you did as well, where you went in and said, well, if I have to just find by just giving the word Hadoop, you saw that just in nationwide in US, there were 14,000 plus jobs. Or even if you just, just look at entry level, right? You may say there were like, more than 1,000 jobs, 1,200 jobs at the entry level for Hadoop. So once again, the reason you went through and read about a lot about Hadoop, you may think this is a first generation kind of a technology for big data. Why are we reading about it? Why are we studying about it? I'm just showing you why. I'm just telling you why we're kind of doing that, because still many companies out there that use Hadoop. There's, Hadoop is still, is in the job market. There are many, even if they have some, if they have been using Apache Spark or anything of that sort, they would still want you to kind of have that experience of Hadoop. So that's the reason why the learning that you had in week 1 was so important, right? And it sets the stage for the weeks to come ahead, because unless you really know this, even if whatever you've read or known during week 1 is going to be very, very helpful and something very important for your resume as well. Okay, so if I were you, and if I want to kind of just do and look at all the different types of big data or whatever big data sets are available, and in future want to just play with different Hadoop clusters and working with all these different kinds of data sets, then I just wanted to share with you one of the websites. Once again, I don't maintain, manage, or part of the the company that has put up this website, which is a free public website, by the way. And this is on GitHub by someone who's put up this nice public data sets that are available in so many different industries and different places. So you can take a look at it, right? And you can go to this website, and the source, I have provided the source on the bottom of the slide for you to take a look at. Now, so, and I'm not kind of preaching that you install Hadoop on your laptop or do anything of that sort. We are going to do it, right? You are going to do the assignment 1 on a Hadoop cluster that is going to be spun up for you. So that's what is assignment 1. You are going to make use of a cluster that is publicly available, and upon signing up, and that's exactly what you're going to do, right? So after you're done through your assignment 1 and you still want to keep up with that cluster and try with some other data set, there you go. You have a list of data sets here that you can still keep working on. Or if you're going to be someone who wants to practice this after the end of this course or later, when you've learned about want to do it in a cloud, then your laptop, right? Your laptop is not really good enough to kind of manage all that huge data. Well, very soon, and at least by the end of this course, you would know what EMR is, right? On AWS. Very similar, there's something called HD Insight, which is on Azure. Then there's Dataproc on Google computing platform. And you'll see that the beauty is that with just few clicks, and on this cloud environment, you could spin up or start up a huge Hadoop cluster. A real production version of Hadoop cluster can be started in a matter of minutes. That's how fast and that's how powerful. And that's why these cloud environments and these companies or cloud providers have become so huge during the last few years that many companies have really gone on to move all their applications over on the cloud, right? So anyway, so that's another reason why you want to kind of learn about the technology, understand what Hadoop is, so that you can configure these Hadoop clusters anywhere, whether it's in on premises in your company or on the cloud environment. Okay. Any questions?
I think I just have kind of a general question. So we're talking about Hadoop, and we're talking about Apache Hadoop is kind of the software, and that's what powered a lot of the use cases you talked about.
Yeah.
And then we've kind of talked about versions that have gone on from it. And to what extent is Hadoop considered, as very specific software, Apache Hadoop, and to what extent is it considered a general framework from which a lot of big data processing is done on?
So Hadoop is just a framework, right? When we're talking about Hadoop, it's a large framework. It comes along with its ecosystem or suite of tools, you could call, right? Right from HDFS to having HDFS MapReduce and Pig or Hive or Mahout or Zookeeper or and all of that and many more, right? You saw that in the ecosystem, like all that it comes along with that suite of or tools that you could use to maintain and manage your big data. So that's what is Hadoop in a raw form or in a nutshell. What you see in assignment 1 is one of those raw Hadoop clusters, right? Where you are using one of the Linux machines, which is already there somewhere on the cloud, and you get a piece of that to run your commands and see how that whole infrastructure works, basically. So and the reason for putting you into that situation or making you go through that is to just have the appreciation of or at least see how easy it is to even move around things, right? Hadoop is not like a big black box or a monstrous box. It is something that could be easily manageable. It could be a partition on your computer if you install Hadoop on your laptop. It could be a small little partition somewhere sitting on cloud that you have to manage it. You have to configure it, right? It's as, and I know it, I'm trying to make this sound this simple, but it is, yes, as long as you understand the configuration, the technology very well, you'll be able to do all of that, and it becomes very easier. But yeah, to answer your question, it's the framework we're talking about.
Okay, thank you.
Mhm. Any other questions? Okay, so moving on, just a food for thought before we leave the topic and move on to talking about assignment 1. And I do have, and I'm just watching the clock right now, and I know we're quickly running out of time. So just want to, I know, just a food for thought for you to think about. How would you take your learning about Hadoop ecosystem forward, right? How are you going to take this forward? Whatever you've learned. What is your plan to practice the knowledge and skills you've learned during this week? And finally, have you researched in areas to find big data sets for practicing your skills? I gave you one, and there are many more you can search. Trust me, you Google it, you'll find multiple of them, right? And one of the other ones that I could think about right away is Kaggle, right? If you heard about Kaggle, then you can go on to kaggle.com, and there's a bunch of data sets, wonderful data sets, right? That you can really take advantage of. So there's a lot of these data sets that are available, a lot that you can research on and really practice the knowledge and skills that you've learned. Okay. So with that, I'm going to move on to assignment 1. So assignment 1, basically you choose one of the two. And this is the only assignment where you have a choice. So either you go with assignment 1A, which is you access the Hadoop cluster and MapReduce. And this, I'm going to strongly encourage and recommend you all to kind of use this option here, my personal favorite option. And I think in order to enhance the learning, or at least if you got really interested in Hadoop cluster and MapReduce, this is the assignment to work on. But having said that, you still have a choice to write a big data research paper, right? So you can do only one of the two. They're all being put in the assignment link. When you click on that, you will see that in this exact same note. So assignment 1A is basically exploring the basic and yet most powerful distributed data store called Hadoop and the framework that can implement parallel processing frameworks in its ecosystem to store, explore, and analyze big data. And the objective is to gain a basic understanding of Hadoop and its ecosystem by using a simple data set. Once again, we're not making this really hard and complex for you, right? So we've put together a list of things, and I'm going to give you some more guidelines and instructions here, and we'll see if Kate or if Yelena has any more to give. But the point is that we'll definitely, there's going to be a lot of instructions in the description. Please read through and go through it step by step. We have tried to simplify it as much as possible because this is your first dive into the Hadoop world. And so we want to make it easier, at the same time, a little interesting, right? And so, but the point, you will still, when I say simple, please do not wait for Tuesday morning or Tuesday afternoon or evening to wait to work on this exercise. Trust me, you'll not be able to get through it all. You have to start. If you have not started yet, start right away, okay? And see how easier it would get if you start today and right away. You'll find that you will have time to really go through the steps or redo the steps. If you want to just go over it again, just to get an appreciation of, or to get a good understanding of what you did, it's better that, you not just do it once, maybe do it multiple times, right? So it lets you kind of, look at a MapReduce program, and it also lets you kind of run the MapReduce program. It makes you run a pig program. It makes you run Hive and use the power of Hive within this ecosystem. So that's why this is very powerful assignment and exercise, and yet it is simple. And the biggest thing that I'll tell you, the caution here is to read through the steps. before you do this exercise, just go and simply go through all the instructions and sections, understand what you're going to do without even thinking too much of each step. Don't go into too much detail. Just read through it once, make sure you understand it, right? The and I was just going to show you in the classroom, but I know we may be running out of time. So if you guys have already looked at it, and if you have some specific questions, I'm more than happy to kind of change my screen and move on to the classroom, or bring up those files. But there are basically 3 files, right? In assignment 1. There are 2 files for assignment 1A. One file is the description, right? It describes each step. And each step is first to navigate through the Linux system. Like navigation is basically, if you're going onto Windows platform or a Windows system or laptop, you'd want to know how to click on the files, right? How to click on list the files, how to move around different directories. That's exactly the first section. The second section is then to kind of, create certain files, create your own MapReduce program, which is already given. You've been given all this set and all the instructions and the code that you would have to work with, and you just have to follow the instruction. The second file of assignment 1A is the answer sheet. So wherever in assignment 1A, wherever it says capture the screenshot or paste the screenshot below or paste it on the left, please do not do it on the assignment description file. There is a separate answer sheet. So in that answer sheet, you have to, in same questions are there, you just have to, take your snapshot and register it in the answer sheet, because that's the answer, that's the sheet that you're going to submit, okay? So please remember that you're submitting the answer sheet, which is going to be complete, and it is based on the questions that you've been asked in the assignment description, okay? So that's why there are 2 files for assignment 1A. Is that clear? Any questions or any other questions on assignment 1A? Alex and Alex, are you guys good? Did you guys get a chance to look at the assignment?
I've looked at it. I'm still working through the instructional videos at the beginning of this week's content. And I did look at assignment 1 and saw it was 16 pages and saw some of the instructions for starting to get the Linux machine up and running.
Don't get intimidated by the number of pages, please. The number of pages will increase, by the way, right? So get used to it. But the point is that we've tried to simplify things for you. We have tried to come up for every step, everything that we have seen on the screen, or that you can see on the screen, or you can encounter. We've tried to capture that in the assignment, and that's why you would see that it has, this description has grown too long, right? Too huge, and the number of steps are increased. But once you go through each one of them, trust me, none of these assignments, I can tell you for a fact, and Kate and Yelena would also kind of attest to this, that none of the assignments would go beyond 4 hours. Trust me, you would not have to do it in 2 sitting. If you follow the instructions, if everything is going right, your internet connectivity is right, trust me. And I'm telling you this for a fact, because we've gone through this few times. But you tell me, I want to kind of know from you at some point when you've gone through and completed this.
Yeah, it so far it seems very step by step. Like it's going to be hard to mess it up if I'm following directions.
I hope so. I hope so. And please, we look forward to your feedback. So if anything, as I said in the description, it may say paste your picture here, right? And you think, okay, I have to do it here. Why am I being asked in the answer sheet, right? So we may have mixed up things. There are things that we can improve on, and we'll definitely do. So along with what you're seeing, we are going to be doing it as ourselves to kind of look at that sheet and see if there are things or changes that we have to make. Maybe there are typos that we will definitely correct. So we'll look for any feedback that you can provide us at the end. Okay.
Okay. Thank you.
Alrighty. Okay. And then the third the document that is there is for assignment 1B, right? So for this assignment, you have to conduct an independent research based on the questions that are there listed there. When you click on that document, it has got a bunch of questions there. And there's a lot of research. So we try to balance it out, right? As much time you would spend on 1A, you may be spending on 1B or even more. I don't know. Depends on, what you would really like to do and what is your strength here. But yeah, it's going to be, there's going to be some research. There are lots of questions to be answered, and we would look for basically making sure that you've addressed all the questions that we have asked. Okay, but it's a similar, kind of a paper that you may have written, but a paper that has given you guidance on what we are really looking for from a questions perspective, what you should be really researching on. So that's assignment 1B. And for that, as I said, there's only one sheet in there. And what you will, as an output, you're going to provide a paper. Now, make sure that you remember all the instructions or best practices of writing a paper, right? APS format and all that, the way you would have to format the paper, the lining, and maybe taking the length of the research paper and all of that. So whatever the best practices you followed for writing a paper, you do the same here as well. Okay. So these are your definitely the two, as I said, this is only assignment with choice. You're not getting a choice, and from assignment 2 onwards. So take advantage of it. But my vote would still go for 1A if I were you, but I'll leave it to you. Okay. And as of course, if you do 1B, absolutely. I'm not going to say, well, why did you do 1B? Okay. I'm going to take 5 points away from doing 1B. No, far from it. Absolutely not. I will definitely honor both in the same way. So 1A rubric, I know I wanted to kind of go through here, but this is kind of huge. But the rubric, if you go through it, it will tell you that for every step or things that have been asked from assignment 1A have been put in the rubric form. So you getting points for every, that's the reason why those sections are going to be important, because you will be capturing either screenshots or taking some observations down that you'll be capturing and putting into the answer sheet. And we are going to just, validate it against this rubric and say, okay, you've done this, you've done this, and done this. If by chance you miss a section, well, you could be missing out on a chunk of points here. So please remember to go through each statement there and go through this rubric to ensure that you've really covered it all, right? And if any questions, we are there to help you. You can write it to me or any one of us, and we'll certainly jump in to help you out with any, either it's a technical issue. We talked about the ticket, the Salesforce ticket that you can create for Yelena, and also send her an email. And if she needs to, me to kind of chime in, I will definitely as well. Okay. And same, there's a rubric for assignment 1B as well. So take a look at that rubric. Once again, it's covering all the questions that have been asked, and we'll be looking into your paper to ensure that you've addressed all these different sections. Okay. So with that, I know we just at the top of the hour almost, and so just want to, but still open it up for any questions. We still have a few minutes left, so absolutely. And I'm here, by the way. I'm ready to go over, but I'm going mindful of Alex, who's in Germany. So and I know you're past 2:00 right now at night. But anyway, I'm here to address any or answer any questions that you have.
I just had a brief question about a reading we did in week 1 last week.
Okay.
And it was on, sorry, I should have had it pulled up here. It was on the article in Medium, and it talked about the traditional methods of manipulating or processing big data versus the MapReduce method, the Hadoop method.
Mm-hmm.
And I'm not sure I really understood how the traditional method it described differed. It sounded like it was doing exactly the same thing. It was breaking the data into clusters, processing each one and then putting them together to form an aggregate.
Okay. Let me go through that, and I'll take one look at it again. But it may be just showing that if you're not using Hadoop or MapReduce, how would you really process that data? But as I said, I'll definitely take a look at it again to see if what the question that you're asking, and if there would be some way for me to kind of give you a clear differentiator or kind of give you an answer that would kind of help you to differentiate between the two.
Well, what I think it was saying, and I'm hoping this is what you'll clarify if you can now, of course, is it seemed like the traditional method, before MapReduce or Hadoop, was they would bring the data onto the machine in packets. So, you have 200 gigabytes stored somewhere, you load it on a machine, you process it, you take the results, you delete all that data, and then you bring the next 200 gigabytes, as opposed to just operating on all the different machines.
Yeah. Okay. So here's what is the so the traditional approaches, right? Let's say you're working on any data, you would bring that data onto your machine and work on it at once, right? They're all in a single machine, most of it, and you're bringing data to where your processing is, right? In essence, right? In traditional, as a concept, you're bringing the data where your processing is, right? Now, what you're doing in the Hadoop way is you're taking your processing to where your data is. And what that means is that you are really, doesn't matter, your data could be spread out in so many different places and machines that you are really doing processing on each of them, really. Like you're doing the mapping exercise on each of these data nodes, and the reducer is then going to bring all that result together. Remember the MapReduce illustration that I showed you? What it is doing, that each of those files could be on different machines, and the processing works on each of these machines, right? But in a traditional world, you would bring all those files in one place and process it together, right? Which is like huge. It could be really time consuming. It may not be even technically feasible, right? Maybe based on the size of the data. So that's the differentiation. That's the difference they're talking about. Does that help, Alex?
Yeah, that was helpful. I was pretty sure, but I just wanted to be 100% sure.
Okay.
Thank you.
Thanks for clarifying that, so I could help you right away. But good question there. Absolutely great question. Any other questions?
None from me for the time being, but just looking through assignment 1. I'm sure I'll mess it up somehow and have a question later.
Sure, anytime. I said that don't wait for these webinars. The next one is going to be 2 weeks from now. So, definitely don't want to wait for that, especially if you have a question on the assignment or on the reading material. Let's knock it out before we go on to the other, weeks or other assignment, because there are many more to come, and they're going to come at a very fast pace. So as and when you have a question, please, feel free to send me an email. And best is send me an email instead of using the instant mail on the classroom. I mean, I access both, the saying, but I've seen that the emails is better, because this way I've in the past, for whatever reason, I've kind of, almost missed out on a message or two in the classroom because of that instant mailing that was sent out. And thank God I was kind of digging into that. I found that, otherwise I would have lost that. So please send me an email which works better.
I had a question about the when you brought up I think it was Indeed with the different job listings. So something that I've noticed, like as I've kind of gone through like the major here, it seems like each of the different classes almost introduce like a new program or like a new form. It's like SQL, Power BI, Python. Now it's Hadoop. So I was just wondering, as far as like jobs go, is there like a standard, or are these just so that we're familiar, and then whatever the job uses there, we kind of pick that up? Like, is there certain
Love the question.
programs that we're supposed to focus on? Because I guess I'm kind of feeling like I'm getting good at a lot of things.
Yeah, you get like pulled into different direction. Oh, this course said, okay, please search all the jobs in SQL.
Yeah.
But this course says, so okay, very good question. I like it. Thanks for asking this question. Because I'll tell you, I think the reason for taking you through and making you search through the jobs for the particular technology is to just have you understand the need for or why, be kind of using the technology, or what technology that you're really learning is it out there in the market, right? That you should know of. That's motivation number 1 for doing that. Motivation number 2 is to kind of see that, okay, I love Hadoop. I would want to kind of build my career in Hadoop. Yes, in data science, I've learned like 15 different things, but you know what? I want to really focus on SQL. I want to focus on AWS, right? So you should be able to know how to search on a particular technology, as well as, because you may be interested in your, building a future in that technology, or you should be able to search for jobs based on certain jobs or titles, right? You could say probably, okay, let me just put in data science. Absolutely. I would say if I were you, just plug in data science, just plug in the roles, data analyst, or data science, and look at all the jobs that are out there for the role, which may have one or more of the technologies that you've learned during this degree, right? The entire course of this degree here.
And Alex, I can tell you, you're pretty much done learning new technologies. So you're going to be using Python the rest of the course, or the rest of the degree, and AWS. So you'll be using those, you're going to be doing stuff in those two remaining. So we're not going to introduce like another new one. And I understand what you're saying, because Linesh and I have been through this when we got our masters. Same thing, we learned different technologies. And I think the other thing we're trying to do is to expose you to usually some of the best in class. So when you learned data viz with me, Tableau is the best in class. So we wanted you to learn it. And the third thing is we have to find software that is available to students. So that's sometimes very challenging for us to find software companies that will give us educational access for students. Like AWS has created access, or Tableau is giving students access. Those are softwares we have to make sure have support for students. Does that help, Alex?
Yeah, that does. That helps a lot. So we should kind of view it as like an introduction of what's out there, as well as like a way to look into specifics of what we might want to find like a career in almost.
Yeah. And
Okay.
I mean, I would say like in my own career now, now my new career is teaching, but before my career in data science, I used a lot of different tools. So I was using, in one day, I might use Tableau. I would use SQL statements. I would use, I wasn't using AWS, but I was using like a prediction model. So within just my life of working, I was using a lot of different software. Like maybe it's just that I think a lot of places kind of pick and choose. They're like, oh, we really want Tableau. So they use Tableau and they connect it to their, Oracle database or something like that. So does that also help?
Yeah, for sure. Thank you.
And Linesh, do you see that in your work too?
Oh, yes, absolutely. So many tools that we make use of. Power BI, right? We just learned about in Data 220. And that's another one, right? Yeah, and people who love Power BI say, well, I want to do this for the rest of my life. I'm just kidding, but I'm exaggerating here. But what the point is that, oh, I want to start working on Power BI because I love it. So, yep, here you go. You can search on Power BI and not just on a data science role. So you're not limited to, because some of these technologies could also say, well, we'll hire you as a Power BI developer. You don't have to know everything about data science or machine learning or everything, as long as you can build some nice charts and reports on Power BI. Well, good. Okay, we'll hire you, right? So we want you to also know that there are companies out there that may not need you to know all the gamut of tools and technologies within big data or data science world, but just a particular technology in depth.
And sometimes they'll adopt something like maybe some company started with Tableau, and maybe they'll decide midstream, oh, you know what, we're done with Tableau. Now we're going to switch over to, what is it? What's the new one in Amazon? QuickSight? Is that what we're going to use at the end?
No, wait, I'm sorry. Yeah, QuickSight. That's right.
QuickSight.
Yes.
So maybe, the company says, oh, we're not going to use Tableau anymore. Now we're going to use QuickSight. I mean, I change software. Unfortunately, I feel like I change software, every couple of years, whatever was like getting better. So I think that one thing I'm hoping that you get at the end of this course is that you're learning that these are just tools for you, right? I don't want you to walk away and say, oh, I am a cloud expert, because you're not going to be a cloud expert from our classes, but we want you to have the skills that even if you go work in an Azure shop, that you understand the principles of data science. So I don't want you to walk away and say, you know, I'm going to be a AWS expert. I want you to walk away and say, I know data science and I understand how to be a critical thinker. That's really what I want you. That's my goal for you to be.
That's a great add-on, right? Yeah, great add there, Kate.
So hopefully that helps too.
Yeah, that makes sense. It seems like a lot of them are kind of tailored for almost like specific circumstances too. Like the way you can get like a lot of visual things out of some of them and export as PowerPoints, and then some are almost more just like hard coding. And so that makes sense. Yeah, it seems very flexible based on like what your actual task is.
Yeah. But like I said, you're pretty much done, because when you already took 430, you took 430.
Yeah, I'm in 440 and 455, I think it is right now.
Yeah. So you're doing Python stuff. And when you get to
Yeah.
460, you'll be doing more you'll be in AWS even more. So we're building on these classes kind of till the end are building on each other. We know because we needed to build all of your basic skills. So now we're just building. So that's what's going to be happening. It's very exciting. We're very excited about the next couple classes for you.
Yeah, it's awesome. It's been going pretty well so far. Like you were saying with the directions, I've noticed that with a lot of different courses, the very easy to follow, very clear screenshots, you know, boom, 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 like a walkthrough of really how to go about everything, which is extremely helpful.
Yeah, yeah. And one thing that you want to also, well, that brings up a good point here that I want to also mention, that as you go along with these assignments, and we've kind of captured a lot of instructions based on what we would have seen. It could be a few weeks back, few days back, or few months back. And sometimes things change overnight, right? And the screen that would have looked like this, all of a sudden, you know, it changes on you. But if you would have followed the concept of what we are trying to do, if you just kind of keep that in mind and say, okay, well, it doesn't matter, the screen has changed, but I know I want to do this on this screen, so let me find that out. So keep that in mind. Of course, you can still bring it to us and we'll help you with it. But my point is, do not be fixated on what you should see and not see and say, oh my God, you know, something went wrong or not. The screen should have looked like what is in my assignment description, and it doesn't. So don't just freak out or whatever. It may be that things would have changed, and you know, you could just bring us into that conversation or discussion.
There is more. There is also the master's degree in this data analytics. So keep that in mind.
Yep, absolutely. That's a good plug in there, Yelena. I agree with you.
Six courses.
Yes.
And
you know, actually it should be Kate and me should have been putting the plug in for that, because we've been you know, one of the first batch of students, one of the first few batch of students to kind of graduate from that data analytics program a few years back. So keep that in mind. So there are things that you can still continue working on after this degree. You work on your master's. Okay. Any other questions? All right. I know we went over. I promised you an 8 o'clock stuff, but we went over by 15 minutes. But I said 15 minutes, that would be it, right? So I'm glad it's 8:13 right now. That's what my clock is showing. And I should now call it a wrap. Nice session here, guys. Thank you for asking all those good questions. I'm sure it's not just going to help you, but also your peers, your classmates who are going to watch this recording. Okay. And good luck with your assignment and everything that you need to do during this week. Good luck and good night.
Thank you very much.
Good night.
Bye-bye.
Thank you.